Hello everyone to day 3 of Advent of Code. For those who don't know, Advent of Code is a platform or a website where starting December for the next 12 days, each day we get a task that we have to solve and we need to collect in total of 24 stars, and each day has two parts, part 1 and part 2, and both parts give us 2 stars per day. So for today's day, number 3, we have a task called Lobby. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that. An elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department, not that you'd get much further than that without the elevators working. That is, you could if the escalators weren't also offline. But don't worry, it is not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. So, there are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, a value from 1 to 9, and you make a note of the joltage ratings, your puzzle input. For example, we have a bunch of numbers here, so this will be explained now. The batteries are arranged into banks. So this is like a one battery, and each of these numbers represents a bank. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly two batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, the bank would produce 24 joules. You cannot rearrange the batteries. You'll need to find the largest possible voltage each bank can produce. In the above example, in the first line, the largest possible one is 9 and 8. If we would turn them on, which would give us 98, by turning on the first two batteries. In the second example, we have 8 and 9. In the third one, we have 78. And in the fourth one, we have 9 and 2, which gives us 92. So the total output voltage is the sum of the maximum voltage from each bank. So in this example, the total output voltage is 98 plus 89 plus 78 plus 92 equals 357. Basically, with our puzzle input, we need to figure out what is the total output voltage. One thing we also can immediately see and note is that since we cannot rearrange the batteries, we always need to find when we find a first large number, we then need to search for a second number after it. So a good example of that is this example, because we have the 9. Here we have 9, and then everything afterwards is basically gonna get checked. So in this case, we find 2 here. Here we start with an 8, and then everything afterwards leads up to a 9, so that's why we get 89. So this realization will be extremely useful for us in solving today's task. So let's write our code for today's task. We will start off with a naive brute force approach, which will allow us to better understand what this task is searching from us. And because in this case, naive approach would be much more understandable and comprehensible. So we will start off by opening our file with open input example. I have a file here with an example, and we will again write it as f. Now we need to go through each one of these lines and opening a file reads line by line. So we can simply do for battery, sees each line represents a battery, for battery in F. Now one thing I will immediately do is I will do battery.strip. So why am I doing that? Because when we read from a text file in Python, it puts a new line at the end of each line in our file when we are reading from it. This strip will ensure that it removes that new line, because when I was doing this first time, it caused me a lot of headaches and I just forgot about that small detail. But enough of that. Now, once we have done this, we can slowly start writing our function. We will name it calculate voltage, which will accept a battery as an argument. And let me just write here a simple return so I can call it here, calculate voltage, battery. One thing I also want to do is to create a variable that will keep a sum of the total voltage that we have from our batteries. Voltage sum equals to 0. Now we can begin writing our main logic. So we know that searching for a new value, for a next large value in our battery, needs to happen once we have our first largest digit, largest battery bank. We need to search for other largest battery bank right after that one. So we will do that or represent that by creating two for loops. I will start with doing a bank I in battery, and for bank J in battery. This will give us a quadratic time complexity. But as I said, this is a naive approach, naive brute force approach. Later on, I will show a better approach that comes with this. So now what we can do, first small optimization we can do is, since we know that we can start searching right after we find a first correct digit, we can split this one actually immediately by its index, and we can get a substring based on the index of the first for loop. This will basically mean, for example, let's say we have 1, 2, 3, 4, 5, 6, 7 as a battery. If our bank I is equal to 0, maybe better to say is equal to 1, then our bank J will start, oh yes, I need to start from a next one because we cannot have two of the same banks. So we will basically start from here, and then we will search everything afterwards here. So if this moves, this one moves also. Okay, now we can officially begin. Also, I would like to get a value from here, so I will do this as a bank I value in enumerate battery. What enumerate does in Python is basically allows us to get an index and a value while traversing a certain iterable. In this case, we'll be traversing this. We will get index 0, 1, 2, 3, 4, 5, blah, blah, blah. And we will get a value depending on those index respectively, 9, 8, 7, 6, 5, 4, 3, 2, 1, blah, blah, blah. And just to be consistent, I will name this one bank J value 2. Now we need to create our battery by connecting a bank I value and bank J value, and I will make a new variable called new bank, and I will just use a string format because for me it's simpler, looks nicer, so I can just do that. And now I got a string that allows me to that holds those two digits in place. One thing I forgot to add is a variable that will be called max value, and we will start from 0. This will hold the maximum bank combination depending on our battery and our current combination that we have here. Now we can do a max value, and our max value we will reassign it by giving it a maximum between two values, which will be max value itself, and I will just cast these two integers since right now it's a string, and between a new bank. Now what this does is simply gets a maximum value between these two variables. So if our new bank is lower than this, we will return this, otherwise we return the new bank. Pretty straightforward. And now I can just do return max value. Oh, since I'm just calling here, I can do voltage sum plus equals this. And I will come here and just do print f of part 1 voltage sum. That should be it. Let's check if this will work. 357, and if we would check on advent of code, day 3, this would be the correct answer for the example input. And now let's just check our main input, 17,109, which does correspond to the answer that I have received. So let's get to solving a part 2 of today's task. Now you need to make the largest voltage by turning on exactly 12 batteries within each bank. The voltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's voltage output instead of 2. Consider again the example from before. Now the voltages are much larger. In the first example, first battery, the maximum voltage that can be produced is going to be 9876543 and then 4 ones. And in the second one, which was previously 89, it's going to be 81111 8 10 ones and 1 9. In this third example, it's going to be, yeah, you get the gist. So our goal is still the same, to find the maximum, to find the sum of all of those voltages. So let's get started on coding our part 2. But before we begin, one thing that is very important to note is that instead of now doing 2 of them, we need to do 12, which will render this algorithm extremely inefficient, because this previously it was doable like this because we had only 2 pointers. Even with 3 it would be sort of fine, but we only had to use 2 pointers because we were asked to turn on 2 batteries. Now we are being asked to turn on 12, and I don't think I have to explain that 12 for loops is extremely bad. So we need to find a better way on doing this. We will now create a code that will work for both part 1 and part 2, but it will be a bit more efficient, which will help us solve this task much easier and without writing 12 for loops. All of this stays basically the same. In this case, I will just name this now part 1, and I'm gonna create a part 2 variable part 1, just gonna copy paste this, voltage part 2, and calculate voltage, and now I can just do the same here, 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 here. Okay, nice. We will again start by defining our calculated voltage function, and we'll be passing in a battery, of course. In this case, since we want to create a function that will work for both of these, for both parts, we will be providing it a length, which is basically gonna be a representation of how many batteries you need to turn on. So for part 1, we will provide 2, and for part 2, we will provide 12. A significant jump in values. In order to achieve this function to work, we will be using something called recursion. Recursion is a function that calls itself over and over again until a certain criteria is met or until we break out of it. So what can we define here? Well, I will define if our length that we have here equals to 0, then we will just return an empty string. Now, why am I doing that? And you might be wondering, how can this be 0 if we're providing it? Here's where the fun part begins with this algorithm. When we will be searching for those digits, we want to be able to create we need to create our sort of search zones that we will be able to, in which we'll be able to find our largest digits, and they will again follow the same principle as before. When we find a first maximum digit, we need to search from after it. So for example, let's say we have 2, 3, 4, 5, 6, 7, 8, 9, or just this example. Our first search zone, so in this the search zone will be something like this. This will be the first one. We will get we'll try to find the maximum of this search zone, and in this case it will be 4. And then our next search zone will start basically from that 4. Not directly from 4, my bad. We'll start from 4, and then we will be able to search, and our zone might be somewhere around here. But there is a better way to do this, and we'll be defining a sort of a safe search zones, because we don't want to search through more than we should. For example, that algorithm, the formula for that will be we will define it as a safe search zone, and it will be equal to the length of our battery minus length plus 1. So why is that? We will be using this to get a substring of our battery. And in this case, if we have, for example, a length of 15, I believe is here, we will have 15 minus 12 plus 1, which will equal to 4. And then we will again create that safe zone. So in this case, it will be like this. We will get a first 4 of these ones. Once we have done that, once we have the safe search zone, we find a maximum of that safe search zone, and then we start our algorithm again from that index, from the index of the maximum digit, because we need to start right after it. In this case, we can safely ignore this part, and this is gonna be our new battery. And then we will just decrement our length. That will keep constantly going down and down and down. So now we have, since we already got one digit, which is which is our first digit out of all of those 12. We just decrease our length by 1 because that digit covers that one. So now we just need to search for 11 of them. And now if we would go through the same logic, then now we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I believe. Or how much? Yes, I think we would have a 12 of them, minus the length, which is 11, which is 1, plus 1 would equal to 2, and we would be searching for these 2. And now the next largest maximum digit from this search zone is 3, and we will be doing so on and so on. So that's basically the logic behind the algorithm. And now let's just finish writing it. We will call a next digit. We will make a variable next digit, which will be a maximum of our battery. And our ending will be this save search zone. So this basically means from the beginning of our battery to the end of this one. This will be an integer, so this will just tell us at which index we end. And now, once we find our next digit, we need to also get its position, since we want to start from that position. Next digit position will be equal to next digit, battery.find the next digit, and this will return us the index at which that next digit is on. And now we can just write next digit plus, and now we will call this function again, but instead of providing a whole battery, we will provide it from that next digit's position plus 1. Since we don't want to include that position, we want to include the next one. And we will just provide a length minus 1. And that should basically be it, I would hope. Let's check if this is working as intended. If we do, we get a string index out of range. Why is that? What has happened? What has happened? Aha, oops, I forgot to provide a... And now since we're returning a string, I can just cast this to an integer and this one into an integer. And now we should get our answers. Yes, since I deleted from before, it didn't save. Is that true? 207. Oh, yeah, because I somehow managed to remove the battery equals battery.strip. And this is that issue I was talking about that I had. And now we have part 1 is 357, and this is whichever number this is. And if we would check on Advent of Code, this would be the correct solution to our example. And now if we would just run our main one, we can see that this ran in basically 2 milliseconds. I think it can run faster if I would just run it locally on my machine, but that's fine. And this is my correct solution on Advent of Code. So that's basically it. I hope you guys have enjoyed this. As always, any feedback is appreciated. I hope you have also learned something. Until tomorrow, enjoy your days and peace.